Hello.
Hi.
Hi, Andy.
Hi.
Hello, Raj. Jesse. Welcome to the meeting. I got a message from Amanda. She won't be able to make it today. She's going camping. But otherwise, I think people will be coming in a little bit. So, hello, Andy. Welcome. Could you introduce yourself?
Sure, yeah. My name is Andy. I'm currently a rising senior at the University of Albany, studying public health with minors in informatics and studio art. And I'm joining here just as an interest in AI and machine learning, and just with a desire just to learn more. Yeah, we'll see from here. Yeah.
Okay. Well, that's great. Welcome. I know that Jesse has been. We've been trying to do the. We do the internship program, which is usually in the spring, and we try to bring in people. And last spring we had a pretty nice cohort. This spring we had a cohort that wasn't as big, but we had some people come through. So,
Nice.
yeah. Well, Raj, how are you?
I'm sorry.
Yeah. All right. Would you like to give an update for the group here?
I don't have any updates for this week. It's just like same as the ones I gave yesterday.
Okay. Yeah. All right. Thank you. And Jesse, how are you?
Good. Sorry. Yeah, it's been an interesting week for me. So I'm very glad to see you here, Andy. Thanks for coming by. Yeah, but it's been an interesting week for me in a lot of fronts, but pushing things forward. Usually, just for a general introduction, I'm Jesse. I'm lab manager, research coordinator, and I do a bunch of things in the lab. And typically we'll start out with doing like introductions and updates and dive into some other things. I did put a link. I don't know if you don't have to worry about it today, but there's a link in the chat for we use Notion to kind of make a shared notes document for this week. And for people who join the lab or want to contribute to part of it, people are encouraged to take notes on that. But this not vital right now. Yeah, so Amanda won't be here today, and it sounds like I don't know if anyone else will be. I think we can just get started at this point, Bradley. I don't know how you're feeling about all that.
Yeah, that's fine.
Yeah, we may have some other folks joining. We had a few people reach out over the last week or so to go back to. So, but we'll see. Yeah, so I don't know if you. I have a few like general things that I would go through, but nothing too major.
Yeah, that'd be good. We could walk through those.
Okay. I'll just quickly share my screen for this.
So typically the way we do things in the lab, if you want to get involved, is we usually have these meetings on Saturdays, and then we have specialized meetings during the week. And, the Slack is really the glue of the group. So if you go through the Slack, you go through the channels, then maybe there's some conversations there. Maybe there are some meeting items that you want to follow up on. And then, of course, we review the items here in this Notion document. So if you find something you're interested in, you can ask to be involved, or you can go to a channel and solicit some sort of ask if people are doing work on something, on some topical area that you might want to do. If you want to do a project of your own, we certainly give you space for that. So you could say, I'm interested in doing this project. We have people who are also interested in it. We could have, if there's a conversation about some project, you might really get interested in it and try to, follow up on it in the Slack. That's usually the way we get people going. And then, it's really, we try to encourage people to do things, to create artifacts like, talks or papers or something that, they can take ownership of. So, just saying you're interested in a project is great, but then you have to turn that into something. So, even if it's like an exploratory presentation or working together on a paper for some, to be submitted to some venue, then that's good. And that's really where we want to go with, especially like student internships, because, it gives them that experience of working on some part of a project or even leading up their own project. So with that, Jesse's going to go through these items, but that's where they're coming from. They're coming from this kind of model of involvement and getting people involved in different projects and things like that.
Yeah, specifically for UAlbany students, I'm not sure how it is in terms of like their semester structure right now. Sometimes we try to help out, get them like credit, like experiential learning credit, or other like departmental credits. I know informatics. I'm a far more informatics major actually, and I know they do experiential stuff and all these other things. So that's something we can look into either over the summer or in the fall, if you're interested in that. And I guess the one thing that for new people who are watching, and including there probably be people who are watching this video, we do record these particular meetings, and they're public or semi-public. Usually these meetings are public in general, and we have they'll be on YouTube basically. And for those who are watching the lab as potentially joining over the summer or checking it out in that sense, we have a kind of interesting open. The way you join the lab is typically you reach out to us and then we discuss stuff either in the lab or eventually have like sort of a one-on-one meeting too. But it's maybe a different process than other things because we are open source, because we are open science, and because we kind of have a more sort of rolling involvement opportunities. It's maybe less structured than typical research you might do in a particularly for like undergraduate programs or like at UAlbany specifically in this case. Everything's kind of, well, are you going to join this semester or not? And that's somewhat true for us too, but also we have people who have to kind of dip out for a season or a semester or a while and come back in. But for people joining the lab, the most important thing is kind of, aligning projects that are either existing or not quite existing, and like making sure they have something to do. That's kind of our main focus, is like where do we slot that towards. And for just to kind of have a very general this map is currently being updated, but just as a very quick introduction, we have kind of major banners of happenings, I guess. We have sort of technical stuff related to AI, related to biology and AI. We have a really nice kind of a major like spire or pillar for the whole lab is education open source, which I really like, and I think that to be there's a very strong interest in like pedagogy, teaching, education, the nature in which we're developing stuff, like as people doing research in slightly untraditional ways, perhaps. Cognition futures is kind of my main thing. It's the take on like philosophy and cognitive science, and doing a lot of work in the spaces of pushing that forward. Society ethics tech is a banner I also helped to make that kind of covers a lot of different things, from AI ethics to some people have been interested in like machine learning interpretability and operability and things like that, in a more technical sense as well. And these are just different places that we've been at, from BICA, which is brain-inspired cognitive. What's the A stand for? I thought it was interface. But that's not it.
No, it's biologically inspired cognitive architectures.
Okay, that's that one.
Yeah.
There's another cognitive interfaces thing, but ISIL, an international conference on embodied intelligence, which is, I really like that one. The Robot 2022, which was last year in Seattle, and hopefully, I actually was there, which is great. Hopefully, we're accepted to We Robot 2023, which we'll talk about later, which is in Boston. I'm currently in Boston. CSV conference is sort of a data management, maybe almost data engineering as well, like just how to organize a lot of your systems and data. Trajectories in Cognitive Science was a discussion group at CogSci 2021, which is a major event for that whole space. Envision is a wonderful conference series that I don't think is going to happen anymore, but it was one of my favorites. And then NICWIC 2023 was New York Celebration of Women in Computing, which is kind of associated with things from UAlbany and kind of a local homegrown inclusivity, but also technical content there. And then a bunch of our partners and things we've done with. So yeah, very quick overview of everything there.
So I had a question about the map. In the
Yeah.
Slack, you had proposed that we have a sort of a category called learning, development, and evolution, and that was based, I
Yes.
think, on our conversations last week. So where would that fit in here?
Yeah, I don't know. That's a great question, because I could see it being a big macro category,
Yeah,
or I could see it being a sub theme, kind of like developmental AI.
right.
For those who don't know, developmental AI is kind of our endeavoring into kind of like neuro AI, but also like aspects of embodiment from development, aspects of like literally developmental processes in mostly biology, maybe psychology and stuff as well, and incorporating that into kind of a research agenda or a set of positions about developing stuff there. So learning, I think it was learning, development, evolution, is sort of an idea that I'm playing with for how to house. As if you can't tell by now, we're super duper interdisciplinary. We orthogonal is kind of a almost tongue in cheek sometimes, but because we're looking at a bunch of different things in the space around, loosely centered around like artificial intelligence in kind of a classic sense, and in a modern machine learning sense. And we have like dips into biology, we have dips into like cognition, we have dips into even some, what isn't on here, there isn't a lot for like virtual reality. That's kind of a major thing we're looking into, and have been different ways that we haven't. It's been a theme that Bradley's done a lot. And we have some like what Google Summer Code project this year has to do with virtual reality. One of them does, and the other has to do with kind of sustainable open source involvement, open source communities, and practices like that. So this is sort of a slightly outdated map that I'm working to update. I don't know. Do you have any particular, when you think about learning, development, and evolution as a potential concept or a potential banner, where do you see that, Bradley?
I mean, it's kind of like, I guess it could be like a super banner, of course, but
Right.
yeah, I don't know. I don't know where to put this in this map. So I think it's just we're thinking about it a little bit, and maybe it isn't on the map really. It's just kind of like one of these themes that I always talk about our meetings, and they're all archived. That we have these sort of threads that run through multiple meetings, and they're things you can put together, and that's one of the things I want to do more, and I haven't been able to do, or we haven't been able to do, is to find themes, because our meetings are usually pretty topical, and they have like, and Andy, you'll see this, or we have these little features and papers, and they'll hit on different themes, and sometimes there's a theme that emerges from like multiple weeks of talking about some topic. So like, the AI, the VR stuff that we've been doing, and I'm going to do some today, we have these different topics in VR, like different methods or techniques. And, you can watch those like week to week, but then you're coming up with questions and you're coming up with ideas of how they fit together. So that's kind of what this, I think learning, development, and evolution kind of is like this meta theme that emerges from a lot of this stuff. And I don't know if it's on this map, but it's definitely like, something where we can say, well, we've done a lot of like features and thinking about this, talking about this. Why don't we do something around this idea? So it doesn't necessarily fit into these themes, but it is something that we, a category we want to follow up on. And I'm trying to think of a good way to do that, to put that into a way that people can say, oh yeah, this is a theme that's emerging from what we're doing. And there are other themes, like maybe things we don't even think about. Like there might be some themes in architecture, for example, where none of us are really experts in the area, but if you were an expert and you watched some of the things you were doing, you'd say, oh yeah, that's what that is. And it would be very obvious. So, that's, I don't know, maybe like Notion is a good place for that, maybe not. I don't know.
Well, yeah, and we're kind of dovetailing into getting a bit deep in the weeds for like lab management and administration, like branding, public facing stuff. So if your people's eyes are glazing over, like, okay, well, I don't know what to make of any of this. Don't worry about it.
Yeah, why don't we move on to the?
It's more for like, how do we structure bigger projects? But as a side note, two things about that I would say for people who are checking out the lab. Number one of the most valuable things from my time in this lab, more than anywhere else I've been, at a very open and very, we are interested in help learn, like talking and learning and sharing about this is, and it's kind of related to the education and open source. And I think maybe something we should put here outside of mentoring professional development is sort of research specific. You could say professional development or skills, but like the conversations we have in this group, not always in these meetings, sometimes, but like between ourselves and like our Slack channel or whatever else, the conversations we have are very much inclusive and how do we say it? We have open dialogue about how much and how to design research projects and efforts. And a lot of places maybe, are just, hey, okay, I'm showing up to lab today, what am I doing? And the agenda is set by other people. And maybe when you get, if you're in a PhD program, that's different because you're actually, it's your job as a researcher, but getting the experience of setting your research agenda or exploring stuff or defining stuff, having dialogues about how to go about things when you're not in a PhD program, I think is actually super valuable. And Bradley set the lab up that way where it's very much can afford that, which I respect a lot. And the last thing on this sort of macro level, cognition futures and basically society ethics technology didn't exist a couple years ago. There are new things, mostly that someone has, in my case me, but then mostly that someone has said, oh, I really want to develop an idea and then a project and then have other people work or collaborate on this set of ideas around something. And then a lot of sub-projects happen under these banners. And I feel like that's a really amazing thing if people are interested in developing ideas or research projects or having a banner housed here under which they can do some specific things. And that's really, really cool and not always the case. So that's our promo. We just cut a promo for the lab basically.
Yeah.
And there you go. 10-minute promo on why orthogonal lab research education lab is cool. So with that said, first we'll cover some old business. My general updates are it's been a challenging week for some other things in my life, but we've had things are keep moving forward, and on this list, which I'm about to take off this list, with the Bond Sustainable AI conference, which I couldn't really attend at all, and I'm very appreciative for Bradley, basically spearheading all of that stuff.
So that's complete. Yeah, we have the talk that was delivered, and we have a lot of our talks that go to conferences and places like that on our YouTube channel. That was the one. We have this on the YouTube channel. This is a talk on one of the projects that we did for Google Summer of Code, so last year's project, which turned into this open source sustainability tool, which allows, like, if you're running an open source community, you can you can make sure that it stays active, because a lot of times open source communities will fail after a year or so because they can't get the people they need, they can't do the things that they need to do. A lot of times it's a matter of like social coordination, sometimes it's resource utilization, and so this talk was about how to improve those things using computational models of different communities. You build, you basically plug in some values for what your community looks like. You get this set of scenarios that, if I do this, what happens? If I do that, what happens? And then you can evaluate your community. And so just kind of went through a lot of that. This is the conference here, Bond Sustainable AI. So this was like sustainability in AI, which is, actually, I thought when looking through the program, it was a very broad set of topics. And the talk we gave fit right into that.
I don't know if they have a good, their website's a little bit not super easy to traverse. Like, I don't know if I can easily show the program or anything.
I think it's in the overview tab. If you go down, it's right there, full program,
Yeah, so I actually found this. Oh, I guess I'll just
open it up, yeah.
I found this kind of randomly, and I just submitted a bunch of stuff. I submitted a few things to it, and another group I'm working with here is kind of a lab partner, but also that I'm sort of a co-founder for. It's Plot Twisters, and I kind of hoped that we could do a Plot Twisters related thing as well, but they basically said, hey, you can try to do an in-person demo, but we can't. We're only going to let it might not be the same as what we could do here. So we basically got accepted sort of 1.5 or 2.5 times, which is pretty cool. But because it was virtual, it's mostly Bradley being able to do the talk on.
Yeah, it was a virtual talk, so
A virtual talk, yeah. And I forget, is it the next day here?
it's on Thursday. Ours was Thursday, but if you look through some of these topics, they're really interesting. There are a lot of things on digital colonialization. There's deep sustainability. There's like just AI, which is like making AI accessible and worrying about issues of justice, and there ethical questions. So there's a philosophy aspect to it. There are a lot of different topics that it's more than just kind of like running a program and like getting an answer. That's usually the thing we do with AI is we train it on a data set and then we just run it and get answers, and there's not a lot of philosophy involved, or that's the typical model. That's what you'd learn, like say in a data science program, but this is more like there are a lot of different there are a lot of different sort of takes on AI that are not like in that mindset. So
I think it looked. I'm gonna copy this link here.
so yeah, like we
I think they said that the videos will be available at the end, like the end of June.
yeah.
But like I particularly want to watch this because I basically love this concept. Why AI magic will not solve the climate versus thinking what to do about it. It's like, yeah, I'm kind of calling it. I'm slowly writing something. I think on like, I don't know if it'll be just a blog post or some kind of a manuscript, but about like tech washing, and I'm very much like, I'm all about. I find myself as a slight something to note later to come back to. I'm all about. Well, I'm writing a very specific line between. Part of my views are that the technology we have today is almost inevitably mandatory in terms of our ability to see things at a very high level or temporally diverse or developmentally diverse level. And we have it's been necessary for us to get really valuable perspectives, while at the same time completely on the page of, I'm kind of calling it tech washing, I suppose, for now, but AI magic. Like I think that's totally the right way to say it in a lot of ways. AI magic isn't going to solve these other things. There's been some like discussions, let's say, on the Twitter machine and the Twitter universe about this. But like this, this is a little bit of a sub discussion into the Center for AI Safety and existential risk and stuff like that, and we can all have different debates about that. And I guess Blake Richards is saying, "Oh, I don't think it's an existential risk or should be that much." And I'm less concerned about that kind of a debate in some ways, as opposed to this specific thing of there are problems that have existed before computing that just haven't gone away because of stuff like AI magic. I don't think it's going to just we got 2 million more layers on our deep neural network and we're going to be okay now. It's like, no, I don't think that's. I think that'd actually be easier to just make if it was just a computational problem. I think that would be easier than it is. And so anyway, that's a little bit of a how do you really feel about it kind of a thing right there. But yeah, where are you in here, Bradley? There we go.
Thursday at 11. Yeah, there we go. And
they're gonna put plotters in there for whatever reason, but that's cool.
Yeah, the affiliations. Sustainable auditing tool. ethical, sustainable engagement for open source communities. So it was definitely, this idea of auditing we take the idea of AI auditing, which is where you audit an algorithm to say, is this working properly, or is it addressing the needs of society? If you have a classifier, for example, that classifies people into risk categories, is it something that matches the concerns that we have about social inequality or other things like that? So that's the idea of AI auditing. And then we just apply that sort of concept to open source communities through our ideas about sustainability. So yeah, that one there, yeah. So that's getting some views on it in the. Yeah, you don't need to play it in the. Or you can mute it, I guess. But it's about 20 minutes, and it was they liked the talk. So yeah, it was definitely. I didn't get any questions. Wish I had, but I think the idea of doing like this kind of media where you do a presentation and you record it and then you have it available after. Sometimes you give a presentation at a conference and it just disappears. Just like you hear the slides, I have to do this presentation, and then you do it and that's it. I'm a believer that we should recycle these materials so people can see this now on. If we can point this out to people, say this is a good example of the work we're doing, and then people you can build on this. So you can build, say, like another video or another talk that draws from this and kind of continues that work. And I think it helps to kind of advance this line of work, because we have the Society and Ethics and Technology project, which is essentially people grabbing onto some ethical issue about ethics or about auditing or some other topic, and being able to build on that and say, I have something to contribute to this. It could just be like a talk about like reviewing an area, sometimes an area that's most people don't know about, it's pretty obscure. Or it could be something where you build on, do your original research, where you do some research or you build on the state of knowledge of what's out there. And so those are all opportunities to advance the field, and participate in that discussion. And so, yeah, I mean, I encourage, using talks and using preprints and things like that to really kind of move some of our ideas. Sometimes we have some really unique things to contribute, and other times, we're signal boosting other perspectives, which is also good. So, I mean, this is all part of this. Yeah. So done. Thank you.
Yeah, I'm going to move that into the done category. So I think. Oh well, I guess I'll put that here as we just talked about that. Yeah. So that's kind of a brief overview of some things there. But thank you, Bradley, for kind of making that happen in person. I was very not available this week, through some of last week, but I appreciate that a lot.
Yeah.
Yeah. So that's one of our kind of off the list now. And is Beacus still something we're like? Is that a later in the year thing? I keep forgetting when that is.
Yeah, so this is the Biologically Inspired Cognitive Architectures Conference, and we have a paper accepted there. The draft is due by July 15th, which I have on my calendar personally. You can put the date. Yeah, so it's active, and maybe like revisions due by July 15th. It just needs to be it needs to be edited a bit. And then the conference itself is in September. So the conference is a hybrid conference. I think it's supposed to be happening in China in person, but then they also have a virtual component on Zoom. Last year they did this in Mexico, where the conference was in Mexico, but they had a virtual component. Worked out pretty well.
Was it the 15th? Do you remember, or what time was it?
In September, I believe it's like maybe in the 20 to 22nd. I don't know exactly.
Okay, I'll just put that there for now.
Yeah. But
That's
yeah,
good.
yeah.
Great. So yeah, I should actually just list that here too.
Yeah. Yeah, I'm the only person on that paper, but I mean, I still have to put together slides for it, and we still, there might be a participatory component to that as well. I'm not really sure how to handle like that kind of thing where we have a conference and we want to have participation. I mean, we usually do the shared notes documents where if you're watching a virtual conference, you can take notes as you go through and add. So we have these collective note documents where you have like screenshots or notes, and people all kind of contribute to the same document. So we have this list of things that different people have found interesting. But that's good. But I mean, I'm thinking more, more intense participatory opportunities. So, well, I'll think about that. It's not for now.
I put NeuroMatch on here. Actually, I'm going to talk about NeuroMatch too.
Oh, this is the Academy.
Yeah. So that's good for this. These are all here.
So FQXI is done, right? I mean, at least the submissions.
Yeah, I don't really know what category it should be right now.
I mean,
we could probably take it off the list for the time being.
Yeah.
I don't think anything's going to happen there. But all of these here are active. And I'm going to quickly go over them beforehand. So I don't know if we say this explicitly, but open source sustainability was a project kind of development through last year. It started it got a lot of steam in Google Summer of Code. It's something that dovetailed from a collaboration with actually University of Albany too, because we had someone use it for their senior capstone course as a focus for it. Brian McCorkle was sort of the lead person on that, and it became its own thing, which is really cool, and I'm kind of low key, high key proud of that because it kind of expanded and grew and became something useful. And even if it's not really the most refined product or like end result right now, it was a lot of really good experiences for people before, conceptually starting it out over the summer itself with Brian Hussein and Himanshu and sort of their own versions of things. And then Brian had a particular take on it through the fall and into like kind of the spring. So it was a really nice, in a way, this Sustainable AI conference was sort of a capstone presentation for that whole event in some ways. Maybe not true to form for the whole process, but like it was a cool way to see all that happening. Other things to talk about this week before we get anything new are Google Summer of Code. We met yesterday. A brief cognition features related update. I'm actually going to combine these two, I suppose. We Robot Boston and Hyper Digital Designs, and then NeuroMatch. They'll go in this order. But I didn't make a Notion tab for it yesterday, but it actually was quite. It was pretty good. Like we actually had a really good. It's funny because we were gonna. So for those who don't know, Google Summer of Code is an annual summertime event where people can submit projects and then hopefully get accepted by Google to get funding through Google to flesh out their developmental projects over the course of the summer with mentors. In this case, Bradley's a mentor. Myself and Brian are also like co-mentors. But we also try to involve it such that people can join the cohort as well to do things. Like you don't have to be only through have Google approved funding and the Google approved timeline to do some of those projects. So we've been meeting, and this is our third or fourth meeting. And we had a meeting yesterday. Those meetings are noon. Noon Fridays. People want to join, either kind of talk about both the summer project specifically, then also open source in general. I don't know if you want to say anything about that or about yesterday's meeting.
Yeah, so I guess the definitely want to stress GSOC in these meetings, especially when we do them over the summer. But we try to have this open source interest group. So this is an example of an interest group where we have these meetings on Saturday, and then we have meetings during the week on other topics, and we try to do like there's one for open source, there's one for DevoWorm, which is one of the themes or one of the banners that Jesse showed earlier. There's one for Cognition Futures, which we usually do on Wednesdays. And those are all kind of like, working on specific topics. But yeah, we definitely have like an open source interest in the lab. So if you're interested in practice, how to do open source, maybe some of the open source projects we've sponsored, that would be a good place to sort of catch up on that. We try to do, we'll do our GSOC updates there. We'll work out technical problems, but we also want to have like at least one little bit of that meeting about open source and how, just a broader perspective on it. It's kind of hard to learn that in a controlled setting. In other words, like if you're at a university, usually they don't have a class in open source. And it's usually something you just have to learn through experience, which, sometimes is good, but it's nice to have this sort of exposure to things in an ordered way. So this is something, definitely, if you want to attend the meetings, you're welcome to do so.
We had also a very interesting, it was kind of funny because at the start of it, I was like, oh, we're going to have a short meeting or something today. Because we kind of started up and we're a little bit slow at first, but then we got into this really wide-ranging discussion about keeping track of ideas, and it was actually really cool. As a side note, I'm working to kind of make basically segmenting some of the videos into like shorter clips, just so you can kind of like a lot of like podcasts do it now online. They'll have a full-length episode, but then we'll just have someone edit the videos about like some of the cool things that people say or the more interesting parts and put them out. That might be something we look for like support in, or even just having a video editing or social media specific potential intern in the future. But that might be cool. But we had a really nice discussion about maybe the twirly bird concept, but also just there's documenting your code, there's documenting your stuff, and you're kind of like, okay, I'm doing this, and why is this here in the material? But we also had a really nice discussion about when you're doing research, when you're building projects, when you're building stuff, particularly when you go away for a while, how do you capture the headspace? How do you is it notes, or is there other things you can do? How do you capture that which you will forget? It's always interesting to kind of think about this, and this is kind of something I'm studying in like cognition stuff and frontier map related stuff. But like when you're in the moment, you have a lot of these things that are accessible and tenable and graspable in terms of how you're feeling and thinking about. You're kind of aware of the possibility space that you could go into before you make decisions or choices about a project or implementing something. But it's maybe challenging to eventually you'll forget that. You just won't be in that moment anymore. So we had a really nice discussion about like, what do you do with that? And how does that relate to both sustainability of projects, but also sustainability of like your own frames of reference. So that was a nice discussion.
Yeah. All right.
I think we're on chapter 2 for the reading group. This is another small subgroup, Human Use of Human Beings, which is a Norbert Weiner book. Old school cybernetics, commentary on ethics and technology book, which I really like, and I'm kind of a Norbert Weiner fan. So yeah, no meeting this week, but I think we're reading chapter 2 for next week. Amanda's leading that. Amanda's doing a great job of, bringing her energy and insight into all that. So it's great. This week we didn't have a Cognition Futures meeting. I was dealing with a bunch of other stuff and couldn't fully meet this week. But very excited about that. Last week we did some stuff about this. We have been last week I talked a lot about Enya Cepalito. And she's just doing a lot of really interesting stuff recently, or relevant to what we're doing in the Methods Project, which is this whole thing I won't get into right now. But the Methods Project is basically looking at methodological opportunities and challenges in sort of cognitive science psychology spaces, let's say. We have a nice kind of recent history of looking into Francisco Varela and co-authors related works, continuing with Gesture of Awareness, and Unbecoming Aware was a book, Gesture of Awareness was a chapter in a more recent compilation text, which is really cool. We're updating some of the project management for all that stuff. And then we'll talk about this actually a little bit later, the first annual conference on International Society for Philosophy of Mind and Philosophy of the Sciences of the Mind, ISPSM.
So where are we on that abstract?
Yeah, we'll get to that in a minute. Amanda's writing up her own stuff. I'm not quite sure where it is, but I'll tell you a bit more of mine in a second. We covered a lot about Enya Cepalito. We may do a phenomenology specific reading group in the future. We got some more resources for a potential paper on representation. And this is a really nice kind of a like almost debate panel, but a little more constructive than that, about like yes representation, no representation, and then like a third view on it with all this group of people, which is quite interesting. Russ Poldrak, Enya Cepalito, and Michael Anderson or something like that. And also kind of, I really like this. I'm glad to come back to it. I'm really curious about ethics and phenomenology in the sense of, and this relates to some of my interests in like neurodiversity and even like disability or like different embodiments, and how phenomenological views can support some of those, how we talk about individual experiences at a subjective level or a personal first person level is kind of related to acknowledging some of those differences. And some aspects, certain takes on phenomenology are very, yes, like affirmative of those diversity of experiences. And I think that's a very interesting thing I want to look into more ahead. Avery's work, so I'm just going to skip over. Amanda had a nice comment on neurodivergence. And then ahead, we'll be looking at, we looked at Evan Thompson's chapter in this book, and then ahead we're looking at Velman's book, I guess. So I'll leave it at that for now. Yes, we're about to get into, I'll do that. Oh, where did it go? It's not here. Well, let's put that on the list too. I think it's the easiest way to say, yeah.
Okay.
So where are we with that? Quickly, I'll say frontier map. Well, I guess I could do it like this. It's related to it. Amanda is working on. I guess her embodied neurophenomenology paper. I don't think she's put a draft. Whoops. So as I mentioned, we just talked about the conference. Well, this is really jumping around for some reason. I just do this. Yeah. Okay. Amanda is putting together a draft on that, and I'm not sure where she is. I know she's not here today, so I'm not going to speak too much about it. I'm actually doing a frontier map related submission. I don't think anything's in this stub yet.
And what is the due date for this?
2 weeks. Basically.
Okay, so good. Yeah, we have time.
I
I just want to make sure we don't run out of time. Yeah.
Yeah. It's a very brief abstract at this point for this stuff. And I think it's like 500 to 1,000 words for these papers, and we talked about doing symposia. I don't think that's going to happen. I'd love to, but I'm not sure about that. But basically, Amanda's working on her abstract, and this might be part of it here. I'm not entirely sure what her latest version of it is. We've got 2 abstracts at least. Amanda's going to do embodied neurophenomenology. I'm going to be doing one on basically frontier map, in the sense of. Oh, actually, am I doing that for this? I'm getting a bit confused with hyperdigital designs. I think I'm doing a frontier map related one, or is it just going to be on the methods project? I forget.
Oh, maybe it is methods. I think it is methods.
It might be the methods one. I think I'm going to get confused with the other thing here, with this guy. Yeah, but either way, there's progress on that front. We'll be definitely talking about that this week. We didn't meet for the reading group, but we met for. Well, Amanda said she was going to work on her paper that time. She's not here right now, so I'll catch up with her after that. But there's definitely stuff here. I actually look forward to this event a lot. The event itself is in like late November or later in the year, so there's a lot of time beyond just submitting the abstract. And I'll mention Frontier Map a little bit later too. This is really large here. Yeah, sure. So, as a reminder, for anyone who applied to Neuromatch Academy, I think it's June 7th. So I got accepted to the deep learning. I'll just show what it is for people who don't know. Yeah. Neuromatch is a really, really amazing group of people. They came together over the pandemic era to start putting together these online events and conferences, and now summer schools. Summer school, they have different tracks from computational neuroscience track, deep learning track, and also climate match track, which Climate Match Academy, which is kind of about computational methods for climate science, which is sort of a new partnership that kind of added on to it this year. So that's all really cool. It's kind of, if you really want to join, maybe you can ask really nicely and try to find your way into getting in now. But it's basically past the acceptance period, and it's just kind of like confirming, hey, if you're going to do this, you have a few you had like 2 weeks to say you're going to participate in the summer school or not. I am close to doing the summer program. I just have some other things going on that I'm not entirely sure the deep learning one about mistake. But reminder, if you did apply, let them know soon. Also, there's still a huge need for mentors and TAs. So if you have experience and would like to be at a higher level, the more mentors we have, people who are very experienced with deep learning or computational neuroscience, the more people can be educated, and it's kind of a people get paid when you're a mentor. When you're a TA, you get paid, I guess I should say. But mentors and people helping out, a lot of there's a heavy volunteer component, I should say. So it's a great thing to contribute to if you have time or want to get involved in it at that level. So
Yeah,
I know we're really moving.
We'll be reviewing the materials for NeuroMatch in the meetings week by week. So it's only a couple weeks long, but each week there's a lot of material, and I'm going to try to find a way to condense it so that you get a taste of it, even though you're not actually doing it. And so I think that's a good way to reuse those materials and kind of, maybe think about, maybe the way we'll do it is think about like how we can apply it to the work in the group. Maybe like thinking about where it fits into our projects and things like that. Because I think we've done this in the past, but it's kind of like been a brain dump where you say, oh, here's what they did, and then you're like, how does this fit into anything? It's very hard to make that connection. So I want to try to make that connection a little bit more this year.
Yeah. I know also, to step out for a second, I know we're throwing a bunch of different topics at people right now, so there's no expectation for people to know all these things. It's just these are current events that we're sort of associated with or have things been discussing in the lab. So it's not required for everyone to know everything, but as part of our general meeting, we go through a bunch of stuff. So don't be overwhelmed by it if it's all kind of whoa, a lot of stuff here. But that's just kind of just a place for us to come each week and talk about all these different things that are going on.
Why don't we finish up on this part and then get to some... Yeah.
What was I going to say? Yeah. So outside of that, the last two things in this general section are we wrote about Boston. We have two wonderful submissions. I don't know if they're here. Yeah, they are. Well, one of them is right here. I ended up doing one for plot twisters, which is working title right now of imbuing nuance and self-reflection in digital worlds, plot twisters, or basically edtech startups, quest for professional technology development. I think I refined the title actually a bit more than that. It's like the first working draft here. But basically, it's sort of the plot twister story. For those people who don't know plot twisters, it's I'm working with some other friends and colleagues to make an edtech startup game. Basically a digital world, a virtual game world that involves some aspects of self-reflection and emotional literacy, and we're designing sort of an algorithm that's modeling some emotional constructed emotional things, like how emotions are made in a kind of a Lisa Feldman-Barrett sense, but other theories as well, and trying to create sort of informed experiences for the user, and also dialogue and really cool ways of relating personal experience to the game world and environment. So that's kind of what that's about, sort of the process of doing that, and at a computational level, at a research informed level, and we're making kind of a startup around this idea, which is challenging and interesting. So that's kind of one submission. The other submission, there were a bunch of things here. I ended up submitting something for Frontier Map, which is sort of my own baby project, and kind of combining some generative AI stuff with Frontier Map, about how Frontier Map is sort of a process of having people go through learning or demarcating different fields of study, or when you're new to a field, how do you understand kind of the debates or the timelines, trajectories, and the key things in that field when it's interdisciplinary, when you don't have a lot of clear landmarks? How do you go through the process of finding landmarks or reference points in fields of study? And so I'm kind of working on that paper for a bunch of things. Been a long time coming, that concept. But it's going to be part of it. We wrote about submission, but also hyper digital designs, which quickly I'll show. We have, I think there will be two things at hyper digital designs. One of them is going to be also plot twitches related. Jenny's sort of a organizer or speaker at the event, and she's going to be doing some stuff with plot twisters, and that's related to the Diverse Intelligences Summer Institute, which is really amazing, and I've been applying there for years, and it's hard to get into, but it's a wonderful event. So I missed it this year, but it was really good. But really cool stuff there. There'll be stuff for plot twisters there, and also I submitted something on Frontier Map in a sort of educational sense there too. So now, after all of that stuff, this is sort of like everything that's sort of generically on the docket right now.
Okay.
We're ready to actually talk about new things. So
Okay.
over to you, Bradley.
All right, thanks. Yeah, that was great, Jesse. Thanks for the update. I know it's a little overwhelming when we go over the updates because it's kind of like everything we're doing, but it's always good to keep track of that. So, and then yeah, I'm interested in the frontier maps approach you're doing with generative AI. Yeah, I mean that's of course the next frontier, right? Like, so being able to query like a field of knowledge and seeing where the debates are and things like that.
In short order, like the biggest thing that kind of is the biggest limitation for how I want to use like ChatGPT, for example, is it's not recent. There's a heavy cutoff date, but it's really great. I'm experimenting, and I mean, it's not like I'm adding a whole bunch of new things for it, but like frontier map in the abstract that I've submitted in the paper, like there's sort of the frontier map paper and project, which is sort of its own thing, and then I'm saying, oh well, here's how you can kind of use like ChatGPT to enhance it. And I find it actually one of the best uses of ChatGPT is that, like, you can, what I mean by that is like creating context or creating like you can get a really, if the book was available in the past, you could say, oh, well, what were the key topics in this book? What is this? What is Francisco Varela think about phenomenology? You can get an somewhat intelligible answer that may or may not be true, but it gives you a lot of good leads to follow. And so basically incorporating that technology into the frontier map process. One of the hardest parts of the frontier map thing is like, okay, when you're totally starting out anew, what do you choose as sort of maybe not a landmark, but a potential landmark that you were aspiring to move towards?
Yeah.
And I have specific like terminology for that in the frontier map thing, but I think it can help a lot there. I think it's a nice, automated lead generator, if you will.
Oh yeah, I think so. Yeah, and there's been a debate about like how useful is this or how useful is ChatGPT for the truth and for things that you want to know. So like you don't want to be a student and write a paper and say I'm going to use ChatGPT to write the paper, and like there's that we want to kind of resist that urge. But at the same time, it's very useful for finding things in the literature and then following up on them. Like you might use the internet or like a search engine to find your way through a topic for a term paper instead of having, instead of plagiarizing, you would just look up resources and kind of it guides you and you can cite things. So, in a way, like research is almost like a very slippery slope to like just copying what other people have done before. You always have to have the new insight. So, I mean, I think the frontier map gives, you can give like, you can generate new insights. So you can get the landscape and then say, this is the new thing that's missing, or this is the thing that's,
that's kind of the idea, in the sense of, particularly for people who are new and don't like I feel like, because I'm someone who's like changed like career fields a couple times now. Like I remember when I first started international relations, and it's like, wow, there's so many moving things going on. But eventually you get up to a space where you understand, okay, here's sort of the paradigms of discussion that are kind of like in place right now. And then here are the factors that have changed. And you kind of have your sense that your bearings are more set over time. And it takes a couple of years to do that. Like, and I don't think Frontier Maps is a shortcut for that, but more like part of what I'm doing with it is like having these sort of, okay, here's one. I have specific words for it, but I'm just gonna use general words right now. Like, here's a topic I'm interested in. I'm gonna kind of do one pass or one investigation of that topic. I'm gonna do an adjacent topic, and I'm gonna do 2 or 3 of this, and then have these sort of like drill down tunnels into this. And there's a process of kind of triangulating from that. And I feel like in the process, I'm trying to embed like pedagogical things, but also like things that can help both an educator and a seeker, like a learner and a teacher in so many ways. But I think that one of the best things about that, like Frontier Map is like more than just a lit review, I would think too, because it's not just here's seminal works that I'm reviewing, which is a great thing to do, but also what I want to do more than that is that I want it to be a little more of a really intentionally focused on a kind of breadth and depth of a space. And I think one of the keys of that is like, how did you get, like what I actually find ChatGPT a great match for is comparative, maybe not comparative analysis, but like comparative context analysis. Like, how is it like in phenomenology, right? You have hardcore Merleau-Ponty folks. You have, well, I like predictive processing. You have people who think everything's hallucination. You have these sort of ranges of the schools of thought, and no, I would not suggest using large language models to get clarity around what those differences are, but they can kind of help you demarcate. It's almost like a low-grade sonar. Like you can say, okay, there's something here in this space, and it's a little different from this space, and that's where you can do the work there of fleshing that out more. But when you don't know, it will at least give you what a language model is able to give you, which is here's somewhat elegant, intelligible words about this subject. This is not truth, but I was like these like fill in the blanks. Like, oh, here's a sentence that's a complete sentence that we're presenting with a really nice sentence. The content, we don't really know, but it's going to look nice and it's going to offer some demarcation in how the sentence talks about things. And from there, you can say, okay, well, let's go beyond that. And I feel like that's kind of what I'm gonna. That's basically the heart of the We Robot paper will be about that kind of stuff, which is fun and exciting. On that project, and I need to put together. There will eventually be like a web page about the Frontier Map project, so who can see it. But anyway,
all right.
we can move on to this stuff. So.
Well, thanks for that. So I'm going to talk about. I'm going to switch gears now to talking about virtual reality, and we've been going through these sessions on different topics, different methods that are being used. And one of the things that we think about when we think about VR is how we have this boom in, or sort of this proliferation of different commercial platforms. So we have the Meta Quest, we have some of the other smaller platforms. We have the HTC Vive, we have Apple's coming out with a new headset soon. So there are all these different, and then people are creating games, and they're all different games that you can make. And so one of the things you have to think about are standards for what we call the metaverse. And so standards are always important in technology. They help you to focus sort of your efforts on a common set of requirements. If you know anything about developing mobile apps for, say, like Apple, they have very specific design requirements. So they have requirements for, or guidelines. I think they're more guidelines than requirements, but to be in their app store, you need to make the app like usable. And so they have these extensive guidelines or design. You know, the app should behave like this, it should look like this, you should be able to do things with it. And the idea is to make it not only interoperable with different people's devices, but also to make it like usable, like a common usability scheme. So, you know, I don't want to have to relearn how to use a program every time I switch an app, every time I go to a new game, every time I try to use something. And that's, you know, where if I want to go from platform to platform, I don't have to relearn how to use things. If you notice, like the difference between like Apple and Android, or Apple and Windows, you know, the Mac OS and Windows, they look similar. I mean, there's similar usability aspects to them. So, you know, you have features like a desktop, you have features like icons, you have features like, even now you have chatbots embedded in them. They have different names, but they're always basically the same thing. So these are like emerging standards. And then there are all the technical standards that sit beneath that. So all, like, you know, everyone uses Wi-Fi, everyone uses Bluetooth, those sorts of things. So that's why, you know, standards are important for kind of allowing, you know, for like development, allowing for people to use the thing and not have to relearn everything to use something. And of course, if you build a thing that's very different from the standards of the time, you run the risk of people not being able to figure out how to use your thing. So your technology then becomes sort of a niche product at best. So this is about metaverse standards. And so the metaverse has, you know, we've had, if you go back to Second Life, for example, you know, it was a platform where people had avatars, they behave in a certain way, there's certain design features in the environment, but, you know, they didn't really have standards. And you move to today with the current metaverse, they're, you know, kind of conventions, but there are no real standards that are laid out. And it's sort of a top-down thing. There's usually some sort of organization that, you know, sort of figures out what the best practices are, and then they publish those guidelines, and then people try to follow them. So this article is from the New Stack, which is a little, you know, I'll put this in the Slack so you can read it later, but this is the slow road to metaverse standards and how AI fits in. So there's been a very slow road to getting standards up and running. When the internet first became really big in the early 90s, you know, it took a while, but they ended up with, you know, like a web consortium that was a group of people who decided what the standards for the web were. So, you know, you always have these standards groups that emerge in any industry in information technology that kind of try to get their hands around the technology and say, what are the best practices? What are the technical standards we want to use? And how can people access those very quickly so that they know how to design what they're plugging into this platform? So for the metaverse, which, you know, it doesn't have to be Meta's interpretation of that, but it has to be like something that people can experience and recognize and use, and something that's interoperable. So this article is from April. So the Metaverse Standards Forum was launched 9 months ago. So that was in the late summer of 22. We speak to leader Neil Trevette about progress and how AI will impact the metaverse. So this is, there's been a lot of hype around the metaverse. But after the initial loud posturing of Meta, it dawned on the industry that in order for the metaverse to succeed, open standards would need to be defined, and alliances formed around these standards. So open standards means that you have standards that are shared widely with everyone who's developing, whether you're developing a very small niche game or whether you're developing like a big platform that you want millions of users to be on. So, those design standards should be all, open, and people should be able to meet them without having to adopt a lot of, specialized technology. That was why in June of last year, the Kronos Group launched a new open standards discussion forum called the Metaverse Standards Forum. And so this is Metaverse Standards. This is their website. So they're cooperating to foster interoperability standards. So they have a vision for an open metaverse. Interoperability is the bedrock of the metaverse, and enable multiple disruptive technologies to work together. And then basically, forum establishes pipeline of exploratory and domain working groups. So they have a couple of working groups within this standards group. One of them is 3D asset interoperability, meaning like if you're creating 3D assets, 3D objects or environments or whatever, you want to be able to use certain technologies to do these. You don't want to just create them using, all different types of tools and then, not have a standard. So for example, in the web, they decided to adopt certain versions of HTML, and they said these are the tags that we need in the version of HTML that's currently the standard, and so people wouldn't use non-standard tags so that the browsers could interpret the content and put it and display it. So there's asset interoperability, digital asset management, Metaverse Standards Register, which is where you actually register the standards, and real virtual world integration, which is integrating the real and virtual world, which we've talked about. And then there's some exploratory groups where they're exploring 3D web interoperability. So, how do you interact with the web, with the metaverse versus the web? So I cut my teeth in the 90s on Vermal, which was a language that kind of grew out of HTML, and it was like a specialized language for displaying 3D objects on the web. And since Vermal, there really hasn't been a good interoperable standard for, there are standards for using like plugins and things like that, but like having something that's cleanly interoperable with HTML, say, or some other web-based language, it's not a smooth transition. So there are ways that we need to improve that. Digital fashion wearables for avatars. So people's avatars are very important, and we need to have standards for, designing wearables. You can move from, avatar to avatar if you use different avatars in different environments. Interoperable characters. So, can you transport your avatar to a different application? You need to be able to standardize that. Network requirements and capabilities. Privacy, cybersecurity, and identity. And this is something that, of course, is a big issue in AI as well, and AI ethics and AI safety and that sort of thing. And then technical interoperability and end user troubleshooting. So this is where you have this, how do you solve if you run into a problem when you're using the AI, how do you solve that? Or, so it's very frustrating to like not be able to get through your environment, because there are a lot of moving parts here. So these are all things that people are exploring, and they're trying to come up with different standards for getting there. And so that's the Metaverse Standards Forum. And so they've made some progress on this. The main news today is that the forum, which is over 2,400 organizations signed up to it, has incorporated an independent industry consortium. currently hosts 9 active domain groups ranging on a range of topics. On its homepage, the forum states that its goal is to foster interoperability standards. What are some of the early success stories? One of them is making USD interoperable with the GITF format. So GITF is a file format for 3D graphics that was invented by the Kronos group. So you have this proprietary standard, or this proprietary format that is something that is, you have actually that's where the origins, I believe, of JPEG came from, which is where you had this proprietary format. One time, a lot of graphics programs were proprietary and they were siloed off. So you'd have like a proprietary format for saving the file and encoding it. And then when the web came about, you had to put graphics up and download them onto different machines. It became like imperative that these different formats were interoperable. So this is what they're trying to do with 3D images and 3D graphics in the same way that they did with image formats at the birth of the web. So they call their format here the JPEG of 3D. USD is akin to the Photoshop format, and that it's a native format for authoring 3D graphics files. And so the goal is to integrate those two formats. And so this is the kind of thing you want to have for standardization. And as you can see, there are these categories of different applications that people might work with in development. So there are a bunch of different companies that create tools to create assets using open standards. So Adobe's involved, Autodesk, some other smaller companies. Then there are other groups that are interested in runtime engines, ingesting and processing assets. So platforms like Roblox and Unity and Fortnite, so they're games, they're 3D asset creation tools like Unity, there are display technologies like Roblox. There's other companies here as well, 3JS. So you basically have these tools to create assets. Then they have these runtime tools that can take those assets and manipulate them. So you want to have those two groups of people talking to one another and getting on the same page. And then AI comes in through different ways. I don't think people really know how AI fits into VR. So the metaverse can be defined as the connectivity of the web with this kind of immersiveness of spatial computing. But he wouldn't be drawn on what kinds of consumer applications will come to represent it. However, he did comment on several of the technologies that are paving the way to a 3D internet. So the GPU is important. Networking, so going from 5G to 10G is going to be important because you have this intense need for data transfer. There are a lot of these technologies underlying the metaverse have their own hype cycles. So GPUs are in like the high part of the hype cycle. We talked about different, the hype cycles from Gartner, where they talk about like how things have this peak hype. So things are hyped, they're hyped to a great degree, and then they kind of become disused when people say, well, this technology isn't worth the hype. And then later they start to develop mature applications based on them. So GPUs there are some mature applications, but really it's at the peak of the hype cycle. Web3 is like sort of at the peak of the hype cycle, but where are the applications? 10G and 5G has mature applications. 10G is sort of at the beginning of the hype cycle. So there are different things underlying the metaverse that are at different levels, at different parts of the hype cycle. So I think, you have to keep that in mind as to how to put together sort of the metaverse as like this set of standards. Given the current hype around generative AI, I asked if the forum had been looking into open standards around this. The golden rule of standardization is don't do R&D by standardization or by committee. that's the worst way to do R&D. You need people out there experimenting, doing proprietary technologies to figure out what's working, what's not working. And so the field of AI is moving so fast right now, I wouldn't know what to standardize. So there are tools for sort of, making some of these things, kind of picking candidates that might be good for a set of standards. But it's really too early to look at things that would may be standard to the metaverse. So there are probably going to be these generative 3D models that become sort of dominant. There are things like neural radiance fields or NERFs, where you encode 3D scenes into a neural net. So those sorts of things are going to be very useful. But what the standards are emerging from that are not clear. So that's that article. And then there's this set of standards for XR. So we talked about VR. Oops. Okay, there we go. So then there are also standards for XR. And so XR is unifying reality, OpenXR. OpenXR is a royalty-free open standard that provides high-performance access to augmented reality and virtual reality. So that's what XR is. And so this is actually a specification. This has been released in 2019. So this is a different approach. This is where they want to simplify AR/VR software development, enabling applications to reach a wide array of hardware platforms without having to port or rewrite the code, and subsequently align platform vendors supporting OpenXR access to more applications. So in this case, as opposed to the Metaverse standards, the OpenXR standards are based on, people can subscribe to this sort of set of the specification. They can write their apps based on the specification, and then that would help them sort of through some best practices, I guess. So there are a bunch of implementations of this. So you have an SDK, you have instruction sets. So you can do this for different things like Windows Mixed Reality headset, for Magic Leap 2, for Farjo headsets. So you have these different standards for different runtime standards and I guess content standards as well, but mostly like at the level of implementation. So there's there is this standardization here in XR, but we need higher level standards, I think, for a lot of the emerging, and of course being emerging technologies, it's very hard to keep a set of standards current. So we need to really kind of rethink this every so often, or actually probably every year. This is the example here where OpenXR kind of integrates everything that's going on. So these are different platforms that exist. And then you have the XR app and experience, which is just kind of a standard thing without thinking about how it's implemented. That's standard across all these different platforms. They all have sort of basic components. But if you use, say, like a game engine or something like, the standards are going to be applied differently. And then what they're saying is that WebXR can apply it more evenly across these different platforms. So that's what they're going at. So I think that's good. So hello, Vrushali and Morgan. And it looks like Raj had to leave. Okay, yeah, he had to leave. Okay, so yeah, and that's all I wanted to say about that. I think that's an interesting area. I know Vrushali is probably interested in this, but this will be in the recording later. So we're talking about VR and XR standards in the industry and how you might have standards for design and for the underlying technology.
Yeah. Also, just as a general note, because the meeting is can go a little bit over 2 hours, it's not expected people are here from start to finish all the time. Like people have to come and go at different points as too. Well, the only thing about that is like if you do have something you want to say or present or talk about, please let us know, so that way we can try to make sure you have time to say what you want to say. because it's sort of this mix of, you know, there have been times where I've only been available for a certain time, or someone's in a different time zone, and you know, it's just not a good time for them to start. So it's okay for people to come in and go at different points. But yeah, that said, it was Vrushali showed up. I was like, oh, maybe you were summoned by the VR talk. But yeah, we kind of just got into talking about the VR. Vrushali is doing the Google Summer Code project on VR and XR stuff, so
Yeah.
she's here for that.
So, is there anything that Vrushali or Morgan wanted to say, update-wise, or anything before we move on? Okay. So yeah, if you have anything, just put it in the chat. We can get back to it. Okay. Yeah. Yeah. So that's good. Let me move on to. I'm going to switch gears here quite a bit. We were talking about this is kind of a boring, dry technical conversation, but now we're going to move to something more about it's in the neuroscience area. So this was something that came up on Twitter. Where else? I think it was on Twitter or on Mastodon. So let's see if I can start here. So this was Johann John, and we've talked about him a lot. And this is about gestalts and about the emergence of cognition in the brain. And so I think in the past we've talked about these different issues regarding reductionism versus emergence in the brain. So there are a lot of things you can think about with respect to, how do you describe the mind? Is it something you can drill down to, and is it in the brain itself? Is there an area that, we know that, like in cognitive neuroscience, we've been able to identify certain parts of the brain involved with certain cognitive functions. And of course, some people argue that, those areas are sort of independent, or that they form sort of they're analogous to a circuit. And other people argue that there are these networks that are highly flexible, where there's a lot of, you can define a network, say, for some cognitive function. And so Johann did a post, and this was, I think, last week, where he talked about some of these issues of gestalts, which is actually an old psychological concept where things emerge, patterns emerge, or like cognition emerges. And so I think in gestalts, you look at a pattern, and there's a pattern that emerges from like this thing that I'm looking at. And so it's an old idea that goes back to the 19th century, but I think it's relevant to this debate because, we're talking about emergence in the brain. So this is, I don't remember where this thread started, but I'll go through these screen caps and I'll kind of talk about it here. So in this one, Johann says, using quantifiable measures like reaction times and accuracies, which are measuring, when you do a behavioral experiment, I'll give you a stimulus, and I'll maybe have you memorize a series of 20 things. And then I'll represent those at random and see if you can identify or match the right one, so you're accurate at some rate. Or reaction time. So I show you an object and you have to press a button to say whether it's a blue object or a red object. And your ability to do that quickly or maybe less quickly tells me something about your ability to kind of classify it, whether you absolutely know it's blue or red, or if you have to think about that category. So you can get things like, there are measures like that are very simple to collect, and, can tell us a lot about what's going on in the mind. And that's usually a very linear mapping. So we do this a lot of times in behavioral experiments and psychology experiments, and we say that there's a certain part of cognition that's responsible for that. So for example, it could be recall in memory. If I give you a list of things, you have to memorize it, and then I give you these things to recognize. maybe the order in which they were presented. I can tell about recall. I can say things about memory recall that I couldn't before. So that's the idea behind these sort of quantifiable measures. So using quantifiable measures like reaction times and accuracies, Pomerantz could systematically investigate how emergent features or basic gestalts arise from interactions between components. And so this is from another part of the thread where he talks about this. I think it's this paper here, is Nautilus article, Forest for the Trees, Why We Recognize Faces in Constellations. So, we have like these patterns that exist in nature, or we create patterns. And then, sometimes people say they'll see a face. Or, if you look at the night sky, you can see constellations, you can see certain patterns in the stars. And so that's an example of a gestalt. And so what they're saying is that you can use these quantifiable measures, they're very simple ones, to sort of investigate how these things emerge from the mind, from your brain's activity. There's a mind component that's emerging from that. So these basic gestalts arise from interactions between components. And so Stephen Grossberg, who we've talked about Grossbergian neuroscience, shows how to mathematize gestalt ideas. So Stephen Grossberg has done a lot of work with neural networks, and he has some really interesting takes on neural networks that are probably 30 years old now. And so he talks about how to mathematize some of these gestalts. And then, so actually, Johan has a talk on Grossbergian neuroscience, or it might be one of the meetings that they had. It's chapter 3. Yeah.
This is from one of his Johan. For those who don't know him, is here in Boston. I think he's at Boston University is where he's based, and he said some very inspirational for me, like open reading groups, basically.
Yeah.
One of them, I believe, this is about going through Stephen Grossberg's recent book, and he went through the whole book, and Dr. Johan John, and some of his people in his cohort who were grad students underneath Grossberg. So he has a lot of insight into the ideas, and it was a really great thing to kind of go through. I don't think I was there for all of that one, but they are on YouTube. If you want to read more about it, you can read basically from a Grossbergian lineage of, interpreting that book, that idea, and then Johan's take on it, and going through the book, and also his kind of reviewing of that with some of his colleagues. So it's a very cool thing to be a part of and to see.
Yeah.
And it's available online. So.
Yeah, this is chapter 3 from that book, Conscious Mind, Resonant Brain, and that this is the sort of the meeting group. In this talk, they intertwined art, Gestalt psychology, and computational neuroscience. And then if you go back to the Nautilus article, there's this quote: "Our visual system is more attuned to emergent properties rather than to properties of individual components." So if I give you a list of things to memorize, I can see or recall on different elements. But I could also look and see if you find a pattern within that set of 20 words that may be common letters that they share. And so this is actually kind of what people are arguing, whether GPT-3 can do things like this, where it can it's generating things from a training set. So you're basically doing a psychology experiment where you're giving it information, and then you're asking it to recall information, but you're doing it in a way that's generative. So it's creating sort of new, combining it in new ways that you didn't tell it to do. So this is something, if you think about GPT-3 or GPT-4 as a Gestalt engine, that might be an interesting way to look at it. But this is in the Nautilus article where they talk about this sort of emergent aspect of our minds and how we think about things and how we kind of perceive, individual components of scenes and then recall it as this emergent, set of this emergent object. So, that's one thing here. And then the next tweet, he talks about the Gestalt problem. So I should have like ordered these, but I didn't. So the Gestalt problem, as it's sometimes called, can be cast in various lights. And so, but there's some important sort of properties to it. So the essential concept entails non-additivity, non-linearity, or emergence. So non-additivity is where, you can't just simply add components together to get a gestalt. If I took like a bunch of visual scenes in my room and I added them together, that's not equivalent to a gestalt. It doesn't give me the same answer. So if I say lamp plus cup plus monitor plus book, that doesn't make any sense. But I can view those things together as sort of a new concept of like working area, and that makes sense. So it's like these things that we can define, these larger concepts that we can define. Non-linearity means that it's assembled not in a linear way. You don't just add those things over time; they kind of just emerge from just prior experience, and we don't really know the order. Maybe the order doesn't matter. Maybe it's, there's something else there. So it's it almost sounds kind of magical in a way, but it's actually because we don't have the language to describe these kind of things and how it works. But there is like a time component where things kind of come to be over time. So, our concept of a working space, for example, is where, people have interacted with a set of things over time and they're using it in different contexts, and we kind of generalize from that and come up with this new concept of how those things relate to one another. And then he makes this comment: some reductionists will try to bamboozle you by redefining additivity or sum in non-mathematical ways. So this is from, I don't know what book this is from, but he has a quote here. This could be from the Grossberg book. The Gestalt problem, as it's sometimes called, and this is the thing that he says here. With emergence, however, not only quantitative but also qualitative differences appear as parts are added, such as that wholes take on properties that are novel, unpredictable, or even surprising. So the problem here isn't just that you have a bunch of parts that kind of form this concept, and you can't really describe it by just adding them together. But sometimes when you add parts, those wholes take on new properties that are unpredictable. So again, you can go back to GPT. You can say, maybe it's creating these new sort of combinations, and maybe there are these new concepts that are emerging that are, maybe surprising to people, but it's not really surprising when you think about how our brains do it, or how it basically works, that you get a larger category from like the association of parts. So almost all perception is nonlinear, starting with sensory transduction, and then these wholes have properties that are not reducible to those of their parts, and thus the whole is different from, rather than more of, the sum of its parts. So there's this aspect of novelty and surprise which lies at the core of the Gestalt. So if I add another object to my working space, like a flower, or like a little statue of a clown, it might then become like maybe not a working space. It might become something else, because that clown being there is not consistent with the rest of the working space. Maybe it forms its own category. And so so there's this neat and empirically useful theory of basic gestalts. This is the theory of basic gestalts, TPG or TBG, which will try to place these results within a unified framework. We view this as an attempt to solve the Gestalt problem, or at least a portion of it, by simplifying the problem into more basic components and defining key terms. And this is the Pomerantz reference from 2001, which I don't have, but I think it's, just like a theory of basic gestalts in Pomerantz. Oh, this is it here. Grouping in emergent features and vision towards a theory of basic gestalts. This is Pomerantz and Portillo. This is the whole is simpler than the sum of its parts, J. Willard Gibbs. And from a psychological perspective, this can make wholes easier to detect than parts. So it's easier to detect the wholes than maybe the parts. And certainly if we think about things in the world that are complex, we know those complex things from sort of experience. But a lot of times if we're a reductionist, we're breaking things down into parts. And sometimes those parts are hard to find. So, sometimes they're microscopic, sometimes they're subtle. But then again, these objects are emergent, so sometimes the parts are not obvious because we see the interactions, we don't necessarily see the parts. So this is a theory of basic gestalts. This paper here, I know I just don't have the reference for it, but this is the title, so it shouldn't be. This is the link that he provides, but it doesn't give like the journal or anything like that. The Gestalt problem, as it's sometimes called, can be cast in various lights, but the essential concept, okay, we talked about this already. This part here is, this is sort of the end of the thread. It may be one day, that one day we will all measure grouping strength in agreed upon units. Perhaps words in honor of Max Wertheimer. It's like a hertz, but it's words. So that's like a basic unit of grouping strength, a unit of emergent wholeness. So one of the things about emergence is that it's these parts that are interacting. And so one of the things that you might say is, how strongly are they interacting? If they're not interacting strongly, then they may not form the kind of unity or the kind of unified concept that things that are interacting more strongly will. And so there's a whole literature in the complexity, there's a whole bunch of papers in the complexity literature on the coupling strength of things in an emergent structure. So whether things are weakly coupled or strongly coupled, people have looked at that in terms of complex networks. People have looked at that in terms of emergence as well. So there are a couple papers that I pulled out. This is the article, the Nautilus article by Robert X.D. Hawkins. This is Forest for the Trees, Why We Recognize Faces and Constellations. This is from 2014. This just talks about some of the aspects of the Gestalt where, we find patterns in a bunch of objects that exist in nature, or that we create a pattern and we can see things in it. So this is the constellation Orion. There's no necessarily, obvious thing here. People say, well, I see a belt. But that's just a cultural construct. You've learned that there's a belt here. And again, indeed, if you view it from a certain perspective, it's a belt. Maybe from another perspective, it isn't a belt. So there are all these different aspects of like what our expectations are in this pattern. So the Gestalt just emerges from these set of points, but we also have cultural expectations about what should be in that set of points. And so if those things are, different, if you have a different expectation, you can see a different pattern. And there's a whole class of perceptual experiments where you can look at like bivalent or bistable figures, where if you look at something from one perspective, it looks like one thing, and then if you switch your perspective, where if you reset your eyes, you blink, and then you stare at it again, you can see another type of object emerge from it. So these sorts of things are really based on, expectation, but also sort of looking at it and seeing a pattern. And it's not, it doesn't sound scientific actually, but there is this science of Gestalt and emergence. There's these experiments where they use a lattice of dots, where they look at, like, they ask people to naturally clump dots. And so this goes actually to data analysis, where, if you look at a graph or you look at a scatter plot, you can see like correlations, you can see things that are grouped together. And, maybe we shouldn't rely on that, or maybe we should rely on that more. It just really depends on, what we're trying to do. So there are a lot of things that you can learn from this kind of experiment, where you look at dots and you try to group them based on perception. So you can change the global organization of a set of these things into lines or into clumps or whatever. There is this aspect of proximity. So, dots are not by themselves proximal to any other dot. It has to be within this array. You can then see how the dots are related to one another in terms of closeness. It only makes sense to talk about proximity when at least two elements are present. So that's what an emergent feature is. It's where you have to have things in the same context. You can't rely on the status of any one thing in this array, and then only when you view them all as a group can you make a distinction about their relationship or their coupling strength. So, there are different emergent properties. The law of similarity, objects that look similar. The law of continuity, objects that can be connected by a smooth curve as opposed to a jagged curve. So if you can connect them smoothly, they're more related, I guess. The law of common fate, objects that move or don't move together. So if these points moved in a certain direction, or if they all moved in different directions, we could assess their fate. And the law of symmetry, objects that form a bilaterally symmetrical image. So there are all these properties that we look for in these arrays. Some of them are maybe, kind of useful from a heuristic standpoint. In other words, if we're assessing movement, it's good to see things that move together and understand that those are maybe similar as opposed to things that are moving away from each other. But then again, things that are moving away from each other can be related. Maybe there's been an explosion and things are moving away from one another. That would be, something that would be part of a whole, right? A whole single explanation. So, I mean, there are these different, these different laws that we can point to sort of interpret these individual points as a whole or as a gestalt. So this whole article just kind of goes through the psychology of emergence and the psychology of the gestalt and how people have been working on it since it was early in vogue back in the late 19th, early 20th century. So yeah, this is something interesting to follow up on. A couple more things about this. There are some papers from the literature on the emergent properties of the connected brain. So if you look at how circuits create these networks, as I mentioned previously, people are in this debate as to not only how these gestalts emerge from common stimuli, but how different parts of the brain work together into these networks. And so this focuses on this aspect of emergence, where brain connectivity is sort of emergent, and you get these functional networks that are emergent that respond to these sort of emergent properties of stimuli. And so this kind of goes through this as a review article. There are these different, there's this modular language model, which has different areas of the brain being responsible for different parts of speech and speech production. And then there's this hierarchical language model, which connects these areas in different ways. And so that's the emergent part of it. And so you can evaluate that network as a shifting system of interactions where the coupling strength and the order of operations really make a difference in how things work. And then there's this second article on weak versus strong emergence for the modeling of brain function. So as I said, there's this weak versus strong aspect of interactivity. So things can be strongly interacting or weakly interacting. There's this idea of emergence, which is the same, where you have strong emergence and weak emergence. So strong emergence is where things are strongly related to one another, where there's maybe something driving the pattern, underlying forces driving the pattern, versus weak emergence, which are just things that are sort of associative and don't really have a strong underlying aspect to them. So they talk about these two different types of emergence in collective behaviors and in other things like that. So they're looking at brain networks. They're looking at the way that these collectives come together, how they operate, their causal structure, and so forth. And they talk about strong emergence, and other things like that. There was this challenge back in the 20th century about Roger Sperry, who I guess was he was a neurophysiologist at the time. And actually, it may have been later than that. It may have been closer to the 1980s. That he kind of like was trying to advocate for a model of emergence in the brain. And so he offered a challenge to people to try to find evidence for this. So Sperry had a model of emergence that was not necessarily strongly grounded in data, but it was more theoretical. So Sperry had this idea that higher order mental patterns and programs had their own subjective qualities and dynamics and operate by their own laws and principles, which are different from and cannot be reduced to those of neurophysiology. So this was, where you're doing neurophysiology, but you notice that there are things that maybe don't reduce to circuits or specific parts of the brain. So, how do we deal with those things? And so, is this just the level of psychology? And what is that level of psychology? Is it something that emerges from neurophysiology? What exactly is it? And so, there have been a lot of people who have proposed things for this sort of these models of emergence, but there's not really a standard theory of it. So, and then, there are things that there are these principles of strong emergence. So, a property M is an emergent property of a neurologically complex object. Oh, well, if and only if, and then, M supervenes on properties of the parts of O. M is not had by any object's parts. M is distinct from any structural property of O. And M has a direct downward determinative influence on the pattern of behavior involving those parts. So basically, as I said, there's some strong driving force to the emergence as opposed to just merely things that are interrelated. And sometimes those interrelations are spurious, and we don't really have a method for determining whether they're spurious or whether they have some significance. So that's a problem. The final thing I'll talk about is this article from the Mathematical Intelligencer, which is global and local. And this kind of talks about this global versus local aspect of complexity and of emergence. And it's important in Gestalt psychology as well. So they kind of go through some of these dichotomies here: discrete versus continuous, simple versus complex, global versus local, linear versus nonlinear, all these things. These are forks in the road of mathematical technique. And then they focus here on global and local. So global is where you have this system that has a lot of components. You view it from the top down. You see that there's this very complex system. Escher's waterfall is an example where you have this scene that you can't really explain why this waterfall goes up and then down. So the waterfall comes from water that's seemingly flowing up a slope, and then it comes down back to its origin point. How do you explain that? Well, it's an emergent thing. You can see it, and you maybe don't recognize it at first, but then you see it and you can't figure out how it works. So you could take this and break it down into its local components, and you find out that it's a visual illusion, because this isn't really going uphill. It's just kind of like the parts are juxtaposed in a way that makes it look like that. So you have to appeal to the local aspect, the different parts of it. But the global aspect is that it looks like it's flowing, around in a circle like this. So there's this aspect of the local, this aspect of the global, and we also think about this in terms of algorithms with local minima, global minima. Global being, of course, the absolute answer, and local minima usually being viewed as like these side tracks that don't get you where you want to be. But the local aspects are also very important in sort of solving the global aspect of something. So the local regions are very informative to the global and so forth. And so they talk about this contrast between local and global. that you can't just sum the local areas to find the global behavior, but you also can't ignore the local aspects of the global behavior as well. So they talk about these. This is a very mathematical explanation, although it's accessible, I think, accessible enough for you to understand what's going on with some of these concepts. And so I'll put these in. So they talk about local and global extrema, which I talked about with respect to algorithms, combinatorics, and some other examples. So I'll leave that in the chat, and that we can talk about that or later if people want. But it gives, I think, a good overview of that, all of that. It's a very difficult, it's a very difficult topic to get your head around. But you have to kind of, I think it's important if you're interested in neuroscience, because ultimately, even if you're a reductionist, you still have, like Spiri, for example, you still have this inquiry as to how things actually work. So you can do these experiments on different brain areas. You can do these, and you can find that maybe there's some very strong associations with certain tasks, like doing recall. But then when you get to a broader, more naturalistic context, so you try to generalize the behavior, you find that those circuit explanations don't necessarily work as well, or the single region explanations. And so we want to look at the global state of things, and that's where you get into these issues. Oh, yeah. Jesse said bamboozled by reductionists is a hashtag. So you should put that on. Yeah, you should instigate on Twitter and put that up. Yeah.
That's I've just been authorized by my PI to instigate.
No, don't do that. No, I think I don't think it's bamboozlement. I think it's like, the position is such that I think people sometimes when they get into these debates, they sort of ignore the value of one approach versus the other. And so there is this aspect of understanding the entire brain, which is absolutely necessary for understanding behavior and understanding, cognition, I think, because I think there's been a tendency to just study these various specific systems that don't really have a lot of value outside of, the specific question you're asking.
Yeah.
Yeah.
I regret, because I had to step away a little bit when you got to the global versus local, because I'm going to go back and actually pay more attention to that basically. Yeah. But yeah, I think that's. I mean, if this super falls under the what we call learning, development, evolution banner too, and maybe some developmental AI stuff, but it's hard. Like, it's very hard to figure out how to talk about and demarcate the use of different, at what level you're talking about things, like from phenomenology to neuroscience to cognitive stuff to all of that. And so, like, gaining literacy and gaining also sort of explanatory, how to transition between those explanatory states or something of that nature is challenging. So I really like the thread. I retweeted the thread already.
Okay.
Johan's thread, but I want to actually catch up with the global local thing specifically, because I feel like it's kind of up there with the what do we say, continuous versus discrete, or digital versus analog.
Yeah.
It's not quite the same as those things, but it's in the space of all of those, like, huge, giant, I don't know, what I'm missing the right word, not really axiomatic, but like these the really, really big fundamental debates, I guess you could say, or not even debates, but just like use issues for how we're using these theories and ideas. So big time good stuff.
Yeah, I'm gonna do share my screen again. I wanna kind of draw this out. So when I talk about global and local, that's not just one set of relations. There are multiple sets of relations. So let me show you what I mean. So oftentimes in the brain, we'll have different levels of analysis. We'll have single neurons. We'll have different brain regions. We'll just say like this. I'll just draw some brain regions very informally, like this. And then we'll have the whole brain, and I'll just draw a human brain for the sake of convenience here. Not a very good one. So this is the whole brain. These are the brain regions. Here, we'll put A, B, and C, which are connected together by pathways. And then we have neurons, which are also connected together by connections. And so we have at least 3 different levels here. The first being actually more than that, because neurons are composed of a lot of things. Neurons are composed of, their proteins, that form ion channels, which let ions in and out, which lead to action potentials, which lead to a signal going down to the synapse, which leads to communication. So these connections are actually pretty complex. There are local things going on at the biophysical level that translate into this network forming and being active. This network then is a small component of one of these regions. So you have a bunch of neurons that are firing in different ways, different patterns, and that determines the connectivity of these regions, which then determines their output. So if we think about each one of these little compartments that we're modeling as something that has an output, then we have to determine what causes that output. So this neuron has an output, all right? That output is determined by its internal state. Its internal state then can be, infinitely complex, really, because there are all sorts of things going on in this neuron, from, the production of proteins to even, some people might argue quantum effects. And so there are all sorts of things at different scales that may, contribute to variation. Sometimes you can wash out that variation and just average over it and say it doesn't really have any effect on the behavior of the output, but sometimes it does. The output can be, discrete or continuous, like Jesse was saying, but in any case, that output will, affect the state of this network, or this whole, which is this little network, which then is a component of this whole, which is a set of brain regions, which is then in turn a component of this whole, which is the brain. So you see how this is nested over several different levels of complexity. Now the other part of what I was talking about is the interactivity. So there's this strong interaction or this weak interaction that can happen between the components. So let's take A, for example. You have these networks that are connected, and these neurons are connected by a coupling strength. So 2 neurons can be connected by common activity. They have an output, but notice that they're connected, and if they're connected bidirectionally, they share their outputs, or their outputs are not necessarily shared, but they interact with one another. So, you can have maybe a directional output of this neuron to this neuron, and then this neuron can output to this neuron, and this neuron can output to this neuron, forming this circuit, or this circle, where there's this sort of feedback. So, sometimes there isn't feedback, but sometimes there is. And so that can also affect the global state, because if you have these local outputs that are coming back together on another, on the same system, it's actually affecting the subsequent output of this neuron to this neuron to this neuron. So you get these feedback loops then that are constantly changing their output with respect to one another. And so this is constantly changing the state of this whole. And so some of these emergent properties may seem like magic, but they're actually just kind of like these things that are very hard to measure. So if you had these outputs that keep going back onto one another and forming this feedback loop, which modulates the subsequent outputs and so forth, I mean, we have a mathematical description of this, which is the evolution equation, which is basically where you have, you're looking at like RT plus 1, and it's a product of RT, and then plus some change in something else. I'm just drawing a very generic thing here. But basically, you're taking the current state, the modulating change, and then you're calculating t plus 1. And you can apply this recursively. Sometimes they call this a recursion equation as well. You can just, keep calculating this for this little loop. We have tools to deal with this, but it's hard to do when you have this parallel, the system of feedbacks in parallel. You have all these components interacting in different ways. It makes it extremely hard to actually get, to break this down and analyze it part by part. And in fact, it's impossible to say that this part, to take the states of these parts and just add them up, because it's actually not that simple. You have parts that are influencing the next state, but you really can't understand that unless you understand the action of this one and this element. So you have to view these elements like that Gestalt experiment. You have to view these things in relation to one another. So then you have A, B, and C. You have A, the state of A over time will affect the state of B. The state of B over time will affect, or the interactions between these regions will affect the output of C, which is the output of the brain. The behavior that's emitted that we're interested in the psychology experiment that we're doing. It's a very simple experiment. I want you to look at these dots and say, what do they form? What is the pattern in these dots? And so you're going to look at that pattern. It's going to come into the brain. It's going to be analyzed using assembled through these different local systems, and then you're going to get a global output that is an answer. But it's a very complex process to get there. So that's that. And then one more word about these Gestalt experiments. We have this array of dots, and you say take a shot at classifying these into different things, right? And so a stationary array, you have a bunch of dots. You have, you might say, well, okay, this forms a group, this forms a group, and so on and so forth. When they're uniformly spaced and when they're stationary, you could form groups just based on like this. It's very neat. But when they're moving, or when they're not uniformly distributed in space, it makes it much harder. And actually, that's where you get a lot of the aspects of like these, you might call them spurious correlations in data science. You might call them interesting patterns. But if you have like dots moving together, they're all moving in this direction versus dots moving in this direction. Like I said, this could be like the output of like two flocks of birds moving apart. So these are individual flocks of birds. Or they could be shrapnel from an explosion from a common origin point. And we don't know the answer. They could be a flock of birds that have diverged into two parts as well. So they had a common origin. So, you can tell different things about it in different ways. And when you're analyzing data, when you're looking at like a scatter plot, it's the classic example of the scatter plot where you have these points and you're trying to or like a cluster analysis where you're trying to eyeball certain things. And, you say, well, there's something that looks like it's correlated. And of course, we have tests that don't rely on the sort of the proximity of these points, right? So we can tell using an equation whether something is actually a fit to an equation line. And similarly with cluster analysis, we have ways to evaluate these points using an algorithm to say whether they're actually formed clusters with statistical support. But you can also identify things. There's a tendency in science to say, there's this group of points that are interesting. I'd like to know more about these points because they cluster together. Is this something that's a valid statistical technique in terms of exploratory data analysis? I mean, given what we know about Gestalt psychology, it might be, but it might also be just something that we're imposing on the data. So, I mean, this is and then of course that relates to some of these interactions. Just relying on a science of interactions. We really have to get down our statistical tests for this to make sure that we know that something is a real pattern versus something that's spurious. Because if we don't, then we're just kind of back at the point of magic, and we're saying that there's, okay. Thank you for attending, Andy. We're almost done.
Yeah, Andy, I set up a channel in you for Slack too. So please check out there and say more. I'm happy to meet one-on-one. Thanks so much for showing up.
Yeah, thank you.
Yeah, take care.
Yeah. So that's all I had to say about that. So yeah, I think the emergentist view is great, but there's also this aspect of we have to be careful about how we treat these interactions, the things, the sort of the statistical, mathematical ways that we characterize them, and I think there's like a lot of stuff on like network neuroscience, and there's a common criticism that network neuroscience is, weak, a weak approach because you don't really, these networks are sort of spurious sometimes. Sometimes they don't, we don't know how to map them to function. We say, okay, these things are statistically form a network, form a set of interactions, but how important are they really for the function of different cognitive functions, or the output of different cognitive functions? So I mean, there's this issue that always arises with a lot of this work on emergent brains and things. So there's a lot of work to be done there, and a lot of that debate isn't going to be solved today. But
yeah, it's cool. I mean, I don't know how would you describe this discussion? Like, is this fair to describe underneath the like learning, development, evolution as a theme? I feel like there's also this sort of like perspectives or like the discrete, continuous, global, local, emergent, like non-emergent. Like I don't know. I kind of want to name that discussion. I don't know what to refer to it as. So.
I think there's like this complexity theme that we're kind of drawing from. That could be. I think the learning, development, and evolution. There is this aspect of complexity that runs through it. There is complexity. We do talk about complexity science in this group a bit. And then there's also this aspect of like the global local. I think the global local distinction is really an interesting thing. We've talked about it before. We talk about complexity as part of that. And then discrete continuous is just like how we characterize things. So I think when we characterize things as discrete, we're sort of taking that local aspect in time. And then the continuous aspect is global because we're taking we're looking at sort of emergence over time. So it's I think it's very interesting how I think there are a lot of connections there. I don't know what I would call it. Putting things in a basket is always difficult like that.
Yeah, I don't know either, but I feel like that's something that because I'm we're pretty much at the end of the meeting here, so most people. I don't want to go too long with this, but just I think I'm kind of trying to group certain discussions that we're having because I think there's a lot of really cool stuff we're doing in these spaces, and I might try to organize some clips around that or something. But
yeah, it's like the Active Inference Institute does that with their podcasts. They take parts out of the streams that they do. So I think that's a useful technique to do that.
Nice. Okay, I'm gonna have to head out myself, but this is a really great meeting. Thanks, Andy, and other people checking out the lab today. I'll talk next week.
Anything else before we go from Morgan or Vrushali?
Yes, we want to ask about the Morris water maze experiment. I have two ideas.
Okay.
Let me show you video I got. Like I picture this. Let me share my screen.
Okay.
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 This is something I think I'm gonna make.
Yeah.
Okay.
Yeah. So it's.
Another thing is I have somewhere. Can you see this?
I don't see the video. Yeah, I saw the video and then it stopped. Oh, there it is. Okay, I see it.
Yeah.
And this is also one thing I seen there. Like we have this camera setup and we track the mouse movement.
Okay. Yeah.
So these two things are there, but we cannot do it in VR. So the first one I'm thinking of making, and we will have like ourselves to play kind of thing, sort of game, VR game.
Mm-hmm.
I don't know how to say it. So
Yeah, there are a lot of. We do want to have like a ability to track, like the mount, like the rat, or like just the virtual avatar, because the part of the experiment is like being able to know what quadrant it's in, and so the idea is that it tries to find this platform, and then you see how long it takes where they explore. They explore different quadrants of the space, and so one of the things that they do with this is that if the avatar, the rat or the patient or whatever is only exploring one quadrant of the space, that's indicative of like a disorder in spatial cognition or something. You can also use it to look at like exploratory behaviors, whether the agent is exploring its space evenly or what. So that information is very important to have. I think having the simulation is good, and then having the output of information about the behaviors is also essential.
okay. And do we have the idea of ABM model we sort of making? So I can picture it and list out the assets I need and try to make them. Anything you have like specific or?
Yeah, I don't have any. I'm not working from any models. We have there. I think there are some models online. The virtual maze. You saw that video was the Jove video that was in that list of future videos. Journal of Visualized Experiments. Sometimes, if you look at those articles, they have videos where they show the setup, and they go through like the pool. Basically, you need a circular pool, and there needs to be a platform that appears or doesn't. It's a hidden platform, but it's something that we know where the platform is. And then there's like some arena, so there's a first person view where you're exploring this space, this water, and then there's like a wall around, and the wall shouldn't have any. It should be uniform, because you don't want the avatar to pick up on targets on the wall. Like you don't want pictures on the wall, or you don't want there to be like one side of the wall it's really tall and the other that's not, because there's going to be some bias in where things get explored. So you want to have this uniformly tall wall around the pool, be like basically no patterns on it. It's just one color, and then the water with the platform that's hidden at the platform location needs to be specified, and then the position of the agent when it's moving around the pool needs to be specified. So then that can be dumped out, and you can see the numbers.
Okay. Please share the link of whenever you got that.
Yeah, I'll see if I can find it and send it.
Okay, thank you. That's the only thing I have to ask.
Okay, thank you. Yeah, that's good. And we should, we'll be looking forward to seeing what you can do with that.
Yes.
Yeah, all right. Thank you. And then I guess that's it. Have a good week.
Take care.
Take care. Thank you. Thank you.